One of the 10 is being contested. Last week, OpenAI published 10 new mathematical results and named its next model after them. We covered the whole release. This episode does the opposite. It picks a single line item out of those 10 and follows it for 5 days, because that one line item turned into the strangest week mathematics has had in a while. A conjecture that stood since around 1980. Two completely different counterexamples, landing 48 hours apart, from two groups who had never spoken to each other. A public challenge saying neither of them counts. And underneath all of it, a question about machine-checked proof that almost nobody is asking out loud. Let's go. Here is why we are spending a whole episode on one item. Of the 10 results OpenAI published on August 1st, 9 are the kind of thing that gets checked quietly over months. Sphere packing bounds, binary code bounds, arithmetic circuit lower bounds, quantum parallel repetition, hardness for the closest vector problem, Earhart's volume conjecture, multicolor Ramsey numbers, extremal graph constructions, the first explicit non-sophic group. Those are all serious, and they will all take a long time to settle. But one of the 10 did something none of the others did. Within 5 days, it attracted a rival counterexample, a public challenge, and a specialist argument about whether the statement being proved was even the right statement. That item is the counterexample to Connes's rigidity conjecture. And the reason it drew fire while the other 9 did not is worth naming up front, because it is not that this proof looks weaker. It is that this conjecture has a hypothesis, a precise condition a group has to satisfy before the conjecture says anything about it at all. Most of the other 9 results are bounds. A bound is a number, and a better number is unambiguous. A counterexample to a conditional statement is different. It only counts if the object you build actually satisfies the condition. That gap between proving something and proving the right something is the whole story of this episode. So what is the conjecture? Alain Connes won the Fields Medal in 1982 for his work on operator algebras, and the rigidity question is attributed to him around 1980. It is set out in his 1994 book, Non-Commutative Geometry. The setup is this. Take a group, an abstract set of symmetries. There is a standard machine that turns any group into an operator algebra called the group von Neumann algebra, written L of G. The machine throws information away. Connes asked whether, for one special class of groups, it throws nothing important away. In symbols, whether L of G being isomorphic to L of H forces G to be isomorphic to H. The special class is where the trouble lives. Connes did not say this for all groups. That is obviously false. He said it for countable groups that are ICC and have Kazhdan's property T. ICC means infinite conjugacy classes. Every element other than the identity has infinitely many conjugates. Property T is a rigidity condition from representation theory, and informally, it means the group resists being deformed. The intuition behind the conjecture is that property T groups are so stiff that the algebra cannot help but remember them. Two hypotheses, both load-bearing. Remember the ICC1, it comes back. And note what kind of statement this is. It is not a computation you can spot-check with a bigger machine. It sits at the meeting point of group theory and von Neumann algebra theory, which is a small field with a small number of people qualified to referee it. That matters enormously for what follows. When a result lands in extremal combinatorics, there are hundreds of people who can read it over a weekend. When a result lands here, the pool of people who can genuinely adjudicate it is measured in dozens worldwide, and most of them were not sitting by their inbox on the first weekend of August. August 1st, OpenAI publishes its 10 results and says an internal version of Astra produced a counterexample to Connes. The claim, in the strongest form reported, is not one pair of groups. It is infinitely many pairwise non-isomorphic, mutually commensurable, finitely generated ICC property T groups that all share the same group, von Neumann algebra. If that holds, it does not just break Connes. It also takes down a related question from Soren Popa about whether the map from groups to algebras is at least finite to 1. 1 construction, 2 conjectures. That is an unusually aggressive claim, and OpenAI shipped it with a lean certificate rather than a journal submission. 2 days later, August 3rd, something happens that almost nobody covered. A mathematician named Shuoxing Zhou posts a paper to AR14, number 2608.02327, titled ICC Property T-Groups Without W-star Superrigidity. Same conjecture, different construction. Zhou builds 2 semi-direct products of an elementary abelian group by the product of SL3 over a polynomial ring and SP4 over the field with 2 elements, and changes only the 2 actions, what the paper calls a quadratic fiber shear. The groups differ. The dual actions are conjugate, so the algebras agree. Same target, completely different route. And read how Zhou describes the process, because this is the part that should be the headline. Quote, the construction underlying the main result was found mainly by GPT-5.6 Sol, Codex, and the Dhanu's multi-agent research system, under the author's mathematical guidance. Followed immediately by all mathematical statements, proofs, references, and final editorial decisions remain the sole responsibility of the author. The paper states the 2 works were developed independently and concurrently, dates its own preliminary manuscript to July 27th, and thanks to named human professors. That is a template. Machines find, humans signs, credit is itemized. Nobody voted on it. It just showed up. Now the part in between. On August 2nd, at 3:41 in the morning Universal Time, a PDF was submitted to Hacker News under the title, OpenAI's claimed disproof of Connes's rigidity conjecture is invalid. It reached 33 points and 40 comments. The argument in it is short enough to state on air. Connes's conjecture is about ICC groups. A group with a non-trivial center cannot be ICC, because a central element is its own entire conjugacy class, size 1, not infinite. The claim is that the lean construction produces central extensions by a lattice, so both groups have non-trivial centers, so they sit outside the conjecture's hypothesis. The thread did not go the way the submission hoped. One commenter with evident background wrote that the assertion a semi-direct product with an abelian factor must admit that factor in its center is absolutely false, and that the paper hand-waves the point away later. Another said a mathematician at OpenAI had refuted the claims directly on X. Others noted the same author has posted a claimed proof of the Riemann hypothesis to the same arXiv. The person who submitted it publicly retracted, writing, "A lot of people who know mathematics say the paper is riddled with errors. I regret sharing it here." So on the specific technical charge, the weight of qualified opinion went against the challenge. But look at how the thread tried to settle it, because that is the genuinely new thing. One commenter, Opus 5 says the disproof is wrong. Reply, Opus 4.6 says it is correct, you are not showing it the full paper. Another reported that a chatbot, if forced to bet, would bet on the challenger over OpenAI. A fourth said their bot had burned a week of tokens, checking 40 revisions of the document. This is a public forum attempting to adjudicate a von Neumann algebra dispute by polling language models against each other. Whatever you think of the mathematics, that is a new failure mode, and it is going to keep happening. So strip out the noise and keep the one durable idea, because the challenge was wrong about this construction but right about the category of risk. A lean kernel check establishes that the encoded conclusion follows from the encoded definitions and assumptions. That is a genuinely enormous thing, and it is why these releases are more checkable than any paper proof in history. But here is what it does not establish, and cannot. Whether the formal statement faithfully captures the historical conjecture. Whether a definition quietly weakened the problem. Whether the object you built satisfies the hypothesis the conjecture is about. Call it statement fidelity. It is a human judgment, and no compiler will ever make it for you. And the scale of the Connes formalization shows why nobody checks fidelity by eye. From the repository's own index, the Connes proof is not one file. It is a directory, a statements file, a main file, a property T file, and hundreds of generated row files verifying individual rows of gram matrices and multiplication tables. The basis for one of the two groups contains 73,033 elements. The row files set maximum recursion depth to 1 million and disable the heartbeat timeout entirely, so the kernel can grind through decidable checks without being killed. This is machine-scale evidence. A human reads the statement file and trusts the rest, which is exactly why the two independent constructions matter more than the argument about them. OpenAI's route is a cocycle extension of a symplectic group by a lattice, with a perturbed cocycle giving the second group. Zhou's route is two semi-direct products differing by a quadratic fiber shear. Different mathematics, different tooling, different authors, same conclusion, 2 days apart. Independent replication is the oldest verification technology we have, and it does not care what wrote the proof. If both constructions survive specialist review, the conjecture is gone. If a specialist finds a shared fidelity error, they both fall, and the fact that they fell together will be the interesting part. Now some coordinates, because this is no longer a story about 10 proofs. There is a public tracker of open mathematical problems claimed to be solved with AI assistance. As of this week, it lists 434 claims. 207 claimed proved, 93 claimed disproved, the rest unclassified or both. Its own status breakdown is the part worth hearing. Roughly 40 entries kernel checked and lean, roughly 25 expert reviewed, about 12 disputed or withdrawn, and around 220 still pending review. The single busiest month in that database is July 2026, with 165 claims. That tracker also records something OpenAI does not advertise. One of its earlier first-proof claims, on a Whittaker test vector problem, was withdrawn after author commentary exposed a false support condition. Not a scandal, that is science working. But it is direct evidence that the fidelity failure mode is real and has already fired once. On the Connes entry, the tracker's status reads disproved, with the note that independent specialist review is pending. On markets, and for coordinates only, OpenAI is not publicly traded. Astra has no price and no ship date, and there is no clean red here. At Thursday's close, Microsoft was $496.98, up 1.95% on the day. NVIDIA $219.75. Alphabet $357.90, down 1.25%. None of that is investment advice. On August 3rd, while the Connes argument was running, Quanta Magazine published a piece on why the Erdos problems are falling to AI, and the quotes in it are more consequential than any benchmark. Noga Alone of Princeton, on why he stopped working on Erdos problems. Once AI started to solve them, there is no point anymore. Thomas Bloom, who built the Erdos problem database, naming the real risk. A big problem is AI is being used a lot by people who aren't mathematicians, and no human has read it. His database, at publication, stood at 565 solved and 652 open. And there is a countermodel in the same article, which is the one worth paying attention to. Wouter van Doorn, describing what he actually does now. The eventual proofs that I write are simpler, more general, and easier to read for other people than the thing that ChatGPT came up with. Terence Tao did the same thing publicly on July 21st, posting what he called a digestion of the Jacobian conjecture counterexample, reconstructing it geometrically so the apparent miracles become structure, and noting openly that he used an AI chatbot to discuss the problem and confirm calculations. Not verification. Comprehension. That is the job that survives. So what to watch? And these are all mechanical, checkable events. First, a named specialist in von Neumann algebra is writing publicly on whether OpenAI's constructed groups are ICC. Not a forum thread, not a chatbot poll, a named person in the field, on the record. Zhou's paper already thanks 2 professors by name, which suggests that pipeline is moving. Second, whether Zhou's AR14 preprint clears refereeing at a journal. That is the first of these results to enter the ordinary system through the ordinary door, and how long it takes will tell you more about the next 2 years than any benchmark will. Third, watch the status column on that public tracker, not the headlines. 220 entries sitting on pending review is the real state of this field, and every one that flips to expert reviewed or to disputed is a data point that costs nothing to observe. Fourth, Astra itself is still unreleased, still unpriced, still untestable by anyone outside OpenAI, so every claim about what it can do in general remains unfalsifiable by design. And fifth, the one we would bet on matching most, whether anyone publishes a digestion of the Connes construction. Tao wrote one for the Jacobian counterexample in 3 weeks. The clock on this one started August 1st. That is the deep dive. One conjecture out of 10, posed around 1980, standing on 2 hypotheses, and knocked down twice in 48 hours by 2 teams who had never spoken, one a company model with a lean certificate, one a named human crediting 3 AI systems by name and signing for the result himself. A public challenge that the qualified reading went against, wrapped in a comment thread trying to settle operator algebra by asking chatbots to vote. And under all of it, the thing the kernel cannot certify, that the statement you proved is the statement you meant. The proofs are public, the tracker is public, and the specialists are the only clock that matters now. If you want the machine-checkable version of AI news rather than the press release version, subscribe. We do this every day, and we go this deep when a story earns it.